All right, welcome back. We are in Algebra 1 in the second unit, solving equations and inequalities. And we're to this problem set, number of solutions to equations challenge. Now in the previous video, we discovered that you can know that there's exactly one solution to an equation with one variable on both sides of the equation if the number of that variable is different on one side than the other. That will mean that when you move all the x's to one side, there will be some number of x's. And that will mean that you can put all of the other numbers on the other side of the equation. And so you will end up with x being equal to some number. That is the exact one solution that you would have. But if the number of x's on one side of the equation is the same as the number on the other side, then when you subtract that number off, you won't have any x's left. You'll have an equation with just constants. Some constant equals another. When that happens, there are two possibilities. You get a true equation, like 3 equals 3, in which case, no matter what x value you put into the equation, you get the true equation 3 equals 3. That means that any number for x will be a solution to that equation, which means there are an infinite number, or there are infinitely many solutions to the equation. If, on the other hand, you end up with an equation that has a constant equaling a constant, but those don't actually equal each other, something like -2 equals 10, then no matter what your x value was, you get a false equation, which means you didn't get a solution to that equation. That means there are no solutions. Okay, so we'll use those three sets of conditions to figure out whether there's one solution, infinitely many solutions, or no solutions in this problem set. So this question is, which of the following equations have exactly one solution? So we're looking for a case where there are a different number of x's on the left side as the right, because in that case we can find out exactly what x equals, the one value it equals. So there's -6 x's, there's 103 x's. That's a different number of x's, so this must have exactly one solution. There's -6 x's on both sides of this equation, so if I add 6x to both sides, I get -6 equals -103. Well, that's always false, so this has no solutions. We're looking for things that have exactly one solution. This has the same number of x's on both sides, so it's not going to have one solution. This one has different number of x's on both sides, so it has exactly one solution. Next question. Which of these equations have infinitely many solutions? You get infinite number of solutions when there's the same number of x's on both sides of the equation so that they cancel out, and you have to have the result be that the constants on both sides of the equation are also equal. So there's the same number of x's, 1x and 1x. You take that away from both sides and you're left with -37 equals -37. That's true. So no matter what x value you put in here, you're going to get a constant that equals the same thing. So it's a true solution. That means there are infinitely many solutions. Here we have the same number of x's, and when you cancel them out, you get the same constant. So this has infinitely many solutions. Notice it says choose all the answers that apply, so it could be all of them, it could be 2, it could be 1. We have 2 so far. This has the same number of x's and the same number that results, so that has infinitely many solutions. This has the same number of x's and it has the same constant, so indeed all of those equations have infinitely many solutions. All right, next problem. Which of the following equations have no solutions? Now that happens when your variable cancels out, so you have the same number on both sides, same number of that variable on both sides, so that disappears. And then you're left with a constant equaling a constant, but it's a false equation. It's not a true equation. So in this case, -4x is equal equal to negative 4x's, so that will cancel. You're left with 5 equals negative 5. Well, that's not true. 5 and negative 5 are different numbers, so this is always false. It has no solutions. These x's cancel because they're the same number, and you're left with 5 equals negative 4. Well, that's never true. 4x is not the same as negative 4x. So if I were to add this 4x to both sides, I'd end up with 5 on the right side, and I'd end up with 8x plus 5 on the right side, which means I'm going to be able to figure out the one number that x equals. So that does not have no solution. It has one solution, exactly one solution. And similarly, because there's a different number of x's here, I know that there's going to be exactly one solution. Last one, which of the following equations have exactly one solution? Well, that means the only condition that has to be met is that I have different number of x's on both sides. 19x is not the same as negative 19x, so that has exactly one solution. Negative 19x is the same as negative 19x, so that's going to have either no solutions or an infinite number. These are different number of x's, so that has one solution. And these are the same number of x's, so it either has no solutions or an infinite number. And we're done.